In this tutorial, we will learn about the clock pulses. So it is defined by the command clock and generates a clock pulse at the node name given here. And the second argument, we will have to give the offset time, on time, off time, and the initial clock state. So this is the initial clock state here, which is 1, and this is the offset time, and then the on time and off time will be periodically repeated at the node name given here. And the clock input is synchronized to the CPU time. It takes time from the CPU, and based on that it sets the on time and off time. So let's start with a circuit and see how it works. We will use the first circuit, hello zebra circuit, and instead of setting voltage at the input of the first AND gate, we will use a clock pulse at node 1, that is the input of the first AND gate, and then we will plot the inputs of the first AND gate, output of the first AND gate, which is the input of the second AND gate, and another input of the second AND gate, and the final output. So this clock pulse means that this is the it is applied at 1, which is the input of the first AND gate, and it has a 3 microsecond offset time. Let's increase it a bit further, and the on time is 500 millisecond, and the 400 is the off time, 400 millisecond, and this is the initial state, which is 0. So let's simulate this circuit and see how it works, and finally we will plot the nodes. So zebra, hello zebra dot txt, and this is after analysis with 5 nodes, and the 5 nodes will be plotted. Let's start the simulation. See, this is the here the 300 millisecond of time has been incorporated, and the rest is the periodic. Tutorial, we will learn about the write to file and print to file command. So the write to file basically opens a file, and the syntax is simple: just write to file command followed by the file name with extension, and then the printf command. Where is it? The printf command prints the node voltages to an open file after the simulation ends. So to demonstrate them, we will use the IC circuit that generated a big output, very large output. So we will modify it with the write to file command followed by the file name. Let's say result dot dat, a data file, and modify this print to be the printf. Save this, run this, start simulation. Simulation ends, and let's see if the file is correctly modified. So this is the result.dat, that is our data file, and if you open it with notepad, yes, this gives the similar output as in the command window.